Okay, hello students. Here I'm walking through. This is lesson number 3.2, and basically lesson 3.2 in the PIMA 188 is about what is the learning target is here is what is a polynomial function, graphing basic polynomial function, and graph a polynomial function, that is the end behavior, using zeros to graph the polynomial shape of the graph near zero and local maximum. So this is the learning target. So let me go directly to the practice problem. I want you to really understand because we walked through this in the classroom and you may got confused. So let me do more problems, and this is so that it will help you for the homework 3.2. Okay, so I will straight away go to the very first problem. So the first question is, let's see if the very first question. I'm doing this, all these problems so that it will help you. The graph of all polynomial functions are, so here we have options like continuous, they will give you discontinuous, there is a break, there is a break. So a lot of option will be showing, and I'm going to show that option right here. See, so you see this, whether it is polynomial functions are complete, which means that the graph have no breaks, holes, and so what is that answer for this? A graph of all polynomial functions are, is it complete, continuous, symmetric, disconnected, or discrete? And you can see, which means that the graph have no breaks and no holes. So all it means is it means whenever we talk about polynomial, if it is a linear, it is a line. If it is a quadratic, it is a parabola. If it is a cubic, it is this way. If it is a quartic, it is this way. And you can see it's always a smooth curve without no breaks, no holes, no gaps. So this is it should be smooth and not like this. So if you have that, that's called cusp. Or if you have a line segment and a curve like this, that will be a corner. So this kind of things, these shapes will not be polynomials. So polynomials are always like smooth curves without non-stop. Okay. So this question is let's say another question, but there are two parts. One is this A. So only one of the following graph could be the graph of a polynomial. If you look at this graph cannot be a polynomial because you can see there's a cusp there. So this part which is right here that shows there is a cusp, which is called. So whenever you have a cusp, it is not a polynomial. So which one and why others are not a polynomial? So in this example, the graph could not be that of a polynomial because it has a cusp. Or you could also say this could not be that of a polynomial because it is not smooth also. See, there are two parts which could be correct. This is how you want to figure out. But, so even though there are other options, says that a polynomial because it has a break. No, there is no break here. That's not the reason. And because it does not pass the horizontal line test, no. And the graph, could that be a polynomial? No. So the two answers are only these two. So take note. But if you see the next B, so by just looking at it, you can see this part of B problem is where it is a polynomial. So the graph could be that of a polynomial. That's the main thing. And you can't have, there's no cusp here. So this cusp, so this not, there's no cusp. There's no break also. That's not the right one. This cannot be the answer. And the graph could not be of a, because it is not smooth. No, this is smooth. So this is a polynomial. The first one is correct. And you can clearly see this graph has a break. So it goes this side and then breaks it off and then starts down like this. See? So this is called, there is a break here. And if what is the meaning of cusp? Cusp could be like this, or cusp also could be like this. See? So both sides there are curves and they go this way. That's the cusp. But if there is they don't show the corner here, but remember, so this is the reason this is not a polynomial. The graph could not be that of a polynomial because it has a break. So there is a break. See this break? So that's the break here. And this is the fourth question they're asking. And by just looking, can you see there is a this graph and it goes like that? This is the corner. So this, you cannot have. So the our polynomials never have a corner like this. Polynomials always go this way, smooth curve. So this is not a polynomial because you can say this one, the graph could not be that of a polynomial because it is not smooth. So this is, let's do another example, the third one. Check whether the given expression is a polynomial. If it is, list the degree, the leading coefficient, and the constant term. Remember, what if I write 5? Okay, let me, whatever that given is, how do we figure out? So first of all, this is in the factored form. So better to write in the using the FOIL method. So you can see x times x is, see, I'm using the first. That means x times x is x cubed. Then first and outer, that is plus 3x. Then you do the inner, this two, that is minus 2x squared, and then do the last. So that is minus 6. And clearly, this is a polynomial function. I can write this as px, and the leading coefficient, leading term is this one with the leading coefficient. So the leading coefficient is 1 here. So clearly, the degree is the greatest exponent. So naturally, there are two of them right here. But among them, which one is the leading? Both have leading coefficient 1, and you can see this 1. But here it says constant term is minus 6 and plus 6. But how constant term right here is minus 6? So we have to select this. So this is like a, just wanted to show, we don't know. Okay, we can easily show by just looking. Even I'm going one step ahead and show you. So if I want to know when is this going to be 0, like where does it cross the x-axis? And you can see this x minus 2 is going to be 0 only when x equals 2. That means there is 1 and 2. So there's 1, 2, but the second part is x squared plus 3. And this is never going to be 0. That means the graph 1, 2, 3, 4, 5, 6, minus 6. That means that it is something like this, but it goes through this. Maybe it, so the graph crosses it. This goes down. Okay, now I can't show it right here. Let me see if I can. Let me wipe this off and draw another x-axis. Something like this. 1, 2, 3, 4, 5, minus 6. That's minus 6. And the point is, there's one of the 0 is 2. So 1, 2, that's the 0. And you can see that the 0 with, so 0 with multiplicity 2 because it is raised to 1. So x minus 2 means it is raised to 1. So x equals 2 is a 0 with multiplicity 2. It means the graph has to cross the, pass through the, that means it starts from down. So somewhere you start from down and then start from down, go passes through this. Okay, maybe I don't know. It just goes like this, and then crosses. So that's the main thing. It crosses this, right? Changes the sign. Intermediate value theorem says if you take this is 2. If I take a number to the left, let's say 1.5, and if I take x equals 2.5 and plug this in here, you will see on the left will be the output will be below negative and the right. So this is and somewhere maybe it takes a turn like this and goes this way. See, there is a complex root. That means it doesn't cross the x-axis. It crosses at 2. So one the real 0 is 2, but there are two complex zeros, which it means complex solutions. It means this thing is does not cross the x-axis. So that's the understanding of three three solutions. One solution is a 0, a real 0, and the other two are complex. Question number 4, let's do you check whether this expression, is it a polynomial? No, it's like a rational. Look at this. 4, you can't have x in the denominator like this. So that's not going to be a polynomial. For a polynomial, what is polynomial? Polynomial means sum of the monomials. Each of this, whatever you're writing may be here and the top. This top, the exponent has to be 0 or 1, 2, 3 whole number. They have to be whole number. You can't have a fraction like this or one. You can't have, I can always write this as this thing. I can write it as 4x raised to minus. You can't have this minus 2 like that. So negative exponent property says that this thing is same as this, but you can't have a minus 2. So this is not a polynomial. So that's all you're solving. Let's do the next one. So So there are a lot of options here. I'm going to show this is used to check the left hand and the right hand behavior of the graph of a polynomial. Now remember, if it is just y equals x, it's just going to be a line. If it is y is x square, it's going to be a parabola. If it is y equals x cube, it's going to be something like. See, the end behavior basically means what happens. Let's say this is x axis y, this is x axis y, this is x axis y, and you can see whenever there is x raised to 1, the leading coefficient is important. You can have x cubed plus 4x squared plus 3x like that and minus 7. Main thing is it is x raised to 3. It's a cubic. The degree is 3, right? So it may cross the maximum at one place or maybe something like this also, two places. So whenever it is degree odd, this one, this decide whether it is a linear, whether it's a line or parabola. But what decides the end behavior is the sign, the plus. See this plus sign, so this is when it is plus. But the moment is going to be minus. Now let's say this is y equal minus x squared plus 4x and minus 3. So how the graph will look like is, so it will be x-axis this way instead of it going to upwards. That means on either side. See this when x becomes a very large positive number, the output, that means this y goes up. So the question is, are we understanding this end behavior? Let me little show one more. So if you see this graph, I have drawn a graph which is very kind of cubic because this is going this side down and it crosses maximum 3. So it has to be some x raised to some 100%. There is something here plus something, a coefficient with a square plus sometime x and some number. So this, what does this basically means is, if you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 100, 1000, 2000, 3000, 5000. So as x becomes, so this is what is important is the arrow means when x becomes a very large positive number, that means almost like 1 million, 1 trillion, whatever. So we call it infinity. Then you see this number here. This is an xy, right? That goes here now. So the y becomes big. It goes up here. The y becomes big. We say y also becomes, and you can see it goes up. Up means plus infinity, so we say plus infinity. That's the understanding of end behavior when x becomes very large. But if you see on the left side, if x takes very large negative on this side, so if this is xy, and then again for this point here, this will be xy, and you can see the y which is here is bigger, but now this y is, the output becomes very small. So we say, okay, as x, so as you go x towards the minus infinity, so that means x approaches a very large negative number. That's what that means. And the output y, which is the dependent variable, goes down. So this as it goes down like this, that means takes a lot of uh, negative, large negative values also. So this become minus infinity. So this is the understanding of the end behavior for cubic function. And the same cubic function, suppose it was this way, right? And maybe this was x cube, and I'm gonna write something here, I don't know. I'm just writing maybe this way, uh, plus something x squared, and then plus something x and plus something here. It means if it is positive, this is what it is. But if it is negative, like this, see, the negative, what it does is it flips it flips the graph. That means the whole graph now will be the same graph, something like this, but it will go something like this. So that's the difference. So this side, even x approaches large positive number, the y approaches very large positive. But right now, if you see this case, as x approaches very large positive, the y approaches negative if it goes down. Can you see this is minus infinity and this is plus infinity? That's the understanding of this. And on the left side, if x takes very large negative number, then the y goes down here, right? Y is becomes very large negative number. But the one that you see here is when x, for this part, the second part is when x becomes very large negative value, it goes up. It becomes the opposite, so it becomes plus infinity. So this is the understanding of the cubic function. But what about if it was a parabola or a quadratic? So So that means if the parabola is like this, see? So now this is going up, up. This is called plus infinity going up, up. So it's like if we have x square and with positive number and something x and plus number, this is quadratic in standard form, and that's like plus infinity. But what does the minus do is, so minus flips the graph. So the minus flips the graph over the x-axis, means the same graph now will be like the same. So in other words, here as x approaches the very large positive, it goes up. That means y output becomes plus infinity. But here, when x becomes very large positive number, but the y goes down to negative infinity. Here y approaches to infinity, and that's like opposite of whatever you have here is opposite right here. So we have to take note of that. So in problem number 6, practice problem, you see this. So what decide is used to determine if the left hand and the right hand behavior of the graph of a polynomial function. So it means everything depends on what number is x cubed. Whatever this doesn't matter. If it is x cubed, or maybe it is a quartic 4, or maybe it is x raised to 5, and this could be anything. Okay, what method is the leading coefficient? So this is the leading coefficient, the coefficient that multiplies the variable in the term that has the degree. So this is 3, this is 4. So if it is minus, then you say everything changes. So this decide. So this answer is leading coefficient. So the leading coefficient decide the end behavior, how the graph will go up or the graph will go down. On the left side also, whether the graph is going to be going this way up or the graph is going to down. That's what the meaning of that. So let's check the next one. In this question numbers, even though they recommended us to use the calculator, we will not use the calculator. We can just decide by just looking at it. Look at the leading term. The leading term, let me write this here. Leading term in this example is minus 1/3 x cube. Now I want you to focus on the first thing is what is the degree. So this is the degree, right? The degree is 3. What is the meaning of degree is 3? It means the because it is degree 3, it is down up, something like this. This is the actual how the graph will look like, the shape. But because there is a minus sign, so what it does is instead of going down, instead of down up, it's going to flip. It means it's going to be something like this. See, so no more down up, but it is up down. So I'll take this off. It means the graph will be like this. See. So that means I can just draw the x-axis and y-axis something like this. Look at this. That means this goes up to plus infinity and down it goes. So it is up down. So this graph becomes up down. So it means if I take the inputs are very large x positive infinity, very large positive value. The inputs, this is the output become very large negative. That means y is going to infinity. And that's what they're asking you is y as x becomes plus infinity. This means x is very large positive. The answer is y. This is the answer. That goes right here. So this is y become plus infinity. But if you go see on the left side, if I take x very large negative value this side, and the graph goes up, it means this graph is something like this. Let's forget this part. So it means it's like this is the graph, right? It goes, so this x, y values, see, for every point, the y values go on becoming very large, positive infinity. So that's why we put this is plus infinity. So again, I repeat, listen to the words I say. See, if x becomes very large positive value, positive, uh, if x become very large negative value, the output, this output values becomes, that means the y values become very large positive value. And that's why we say y tends to, there's another word in calculus you will see, tends to plus infinity. I hope that helps. So question number 7 is, so you are given some expression and you can see it's given in the factor form. What basically is, there is a minus, and I'm going to write that like x minus 0 square, because you can always write this as x minus 0 and there is x square minus 4. Now I can write this in the factored form also, and remember this means x square minus 2 square, and you can split this into x minus 2 and x plus 2 because of the difference of square formula. So the whole thing become minus x minus 0, x plus 2 and x minus 2. So the zeros, that means whatever the function is, the qx, this is the one. It is cubic because there's a x, and x. It is, so this x, when you multiply, you get x cubed. But because there's a minus, it's going to be minus x cubed. So there's going to be a leading term, will be this leading term. And then the graph will be something like this. Oh, sorry. Made a slight mistake here. So, so this is 2. That means there is a this. There are two x's here. This means it is, here it is. It already shows you x square, and there's one x and one all together 4. It's not 3. So the leading. So the degree is this one. And imagine if this was plus, then the graph will be like this, like up up. That's the shape of the quartic when the degree is 4. But because the now you have, so because this is minus, so this is minus, so the graph will be something like this. So I can just use the x-axis and y-axis, and you can clearly see this thing to the right side when x becomes very large. That's what I'm trying to show you. So this side, when x is very large positive value, this goes right down. It means y is minus infinity. Okay, that's what it says. And x is infinity, this is minus. But to the left side, if x becomes very large negative, and this goes again down. So it is like down, down. So if it is down, down, then this is y as x. So we're going to write here x approaches very large negative value. Y approaches also very large. So it goes down. That's all. That's minus, minus. But the thing is, how does the graph look like? Because we already factorized this, we know what are the values is at x equals 0. So the three zeros are x equals 0 is 1, 0, x equals opposite of plus 2 is minus 2, opposite of this is plus 2. This is has a multiplicity. So what is the meaning of multiplicity 2? Because it is repeated twice. See this, there is a repetition. So if there is a repetition, if it is a even number, that means the graph has to take a turn, doesn't cross. What I'm trying to say is, all the, let me take this off, how to sketch the graph. So even you can check on the Desmos, but the thing is, we need to, they give you, give you the graph there, but we know the graph is down, down, but then because this zero, this is one of the zeros, and the other two are minus 2, that's minus 2, and this is plus 2, and it has to be down, down. So somewhere here it starts, let's say this is down, so I'll start with the arrow, and then you see if it goes through this, okay, it goes through, and maybe it has to take a turn here because the multiplicity here is, so this is 0, so it takes a turn. That's the important part. And then again it has to cross this 0 and then goes down. So this is how the graph should be. Of course, it's not perfect. What is important is minus infinity down, it goes down. This side also. So on either side, when x becomes positive or x becomes negative, the graph is down, down. So why there is a, there is a turning point onto the left side of 0 and to the right side of 0, you will see the graph is above the x-axis. It's going to be positive. Hope that helps. Let's do it. So without even though they say use the graphing calculator, I would not use the graphing calculator as we are already smart enough. We can factorize it and we can see x raised to 9 is common. So I write x raised to 9. What stays is x squared minus 4, which we can easily write again x plus 2 exactly like that. So what's the difference between the last one? So the zeros are the same 0, x equals negative 2 and x equals plus 2. And so what is the degree? So this is 9 here and this is 2. Together is 9 plus 2 is 11. So the degree is 11. What does that degree is 11 mean? It is down. So it is down and somewhere maybe something is happening like this, something is happening, and then goes up. So that's the meaning of that. There's no minus sign there. So it starts with minus infinity, just down and goes up to plus infinity. See? So it takes, so this side it may take plus. In between, maybe taking, taking almost like because the degree is 11, there will be maybe at the most 10 turns. Now the question is, how does the graph look like? Of course, we are done. Actually, the work is already done. You can see this is a odd degree, so it has to be down, and this is this part. So this is the and behavior. So that means if I try to draw the x-axis and the y-axis, if I try to draw the x-axis and the y-axis, so it means if I try to draw x-axis and y-axis. See, I try to draw x-axis and y-axis. So it means when x becomes very large positive number, okay, and this goes up, so y is very large positive. And on the left side, when x is very large negative number, this goes down, so y is negative. I want to really see how the graph will look like. You can also So if you want to see how the graph, let's see, it is at minus 2. So 0 is one of the point and 2 is another point, 2 and minus 2. So what's the difference between this one and the other one is, so it starts from down, okay, start from down and there is this has multiplicity 9 because it's like x equals 0, 0, 0, 0, 0, and it's like repeated 3 multiplicity. So that's called multiplicity 9. It means, yeah, and this is odd. It means what it means is here this one is not repeated. It's right. They have to cross. So the graph has to cross. So this has to cross, and also it crosses because this is odd. It also crosses at odd, but flattens. So look at this. So it's like it doesn't go this way, but it flattens. It's like it's going this way, like this, see, and maybe something like that. So the graph is still not perfect. Still not perfect. Maybe let me try. So you go this way, and maybe here it's something like this. Something like this, and then goes up. So it's like whenever there is x raised to 1 or x raised to 3 or x raised to 5 and x raised to 7. So what it basically means, this is x, right? X cubed will be something like this. X raised to 5 will be going this way. See the difference? X raised to 7 almost going so much and then like this. So that's the difference between x cubed and this is x raised to 5 and x raised to 7. So flattens around that point. So until here, this thing I will make another separate video. So I hope the one that I done, I hope you guys going to complete. So this part, and I think it is 9, 10, 11 until 16. This I will do a separate video to help you guys. So far, whatever I did, I hope you'll complete your homework in the Cengage. So complete in the Cengage 1, 2, 3, 4, 5, 6, 7, 8, I think 9. I think 9 we did. So we have to do 10, 11 and so on. So see you guys. Hope you work hard and you can always ask me question in the class.